Solve the exponential equation 3 power n squared plus 2 times 3 power n minus 3 equal to 0. Okay, to solve this problem, we need to perform some transformation. That is, we need to transform this term in the brackets such that the problem becomes quadratic and it will be easy for us to solve. So let 3 power n stand for p. So this is our transformation equation. Let's call it equation star. Alright, if that's the case, then we substitute 3 power n for p in this equation. So back to the equation, we now have here, it's in place of 3 power n, we write a p there, p, then squared, plus 2 times, here is p now, 3 power n is p, 2p minus 3 equal to 0. Now we have a quadratic equation, and this equation can be solved by factorization method. So we'll create two brackets equal to 0. So p here and p here. So what are the two factors that will give us minus 3 such that we'll add them up and we get plus 2? One of them must be negative, while the other one will be positive. So we're going to be having negative 1 and positive 3 equal to 0. For minus 1 times 3 is minus 3, minus 1 plus 3 is plus 2. So if that's the case, it means that p minus 1 is equal to 0, or p plus 3 equal to 0. If p minus 1 is 0, it implies that p is equal to 1. If you bring minus 1, this way becomes plus 1. And if p plus 3 is 0, it means a p is equals to minus 3. Now we have two values of p here. So we'll now come back to the transformed expression here, such that we substitute the values of p back to this transformation so we can get the value of n. So we can say from star, we know that our 3 power n is equal to p. Now when p equal to 1, from what we have here, we're going to be having 3 to the power of n equal to 1. And that implies that 3 power n, from the law of indices, we can transform this one to have the same base as 3. And that is 3 raised to power 0, because a number power 0 is 1. And the choice of 3, because we already have a base of 3 here, so that the bases can cancel out, then our n here is equal to 0. Also, when p equal to minus 3, as we have here, so it means that 3 to the power of n is equal to minus 3. But unfortunately, if you look at this, there is no real whole number that you take the power of 3 to the power that will give us minus 3. So in this case, we can say here that this one has no real solution. There is no real solution to this other expression when p is minus 3. So which means that a value of n that will satisfy this equation is when n is equal to 3. So, and that was gotten from the value of p here when it was 1. So which implies that in this equation, when n is 0, let's check if it satisfies this equation. So our 3 to the power of n squared plus 2 to the power of 3 power n minus 3, let's see if it will give us 0. Now when n is 0, we have 3 to the power 0 all squared plus 2 into 3 to the power 0 minus 3. Now 3 power 0 is 1 squared, plus 2 times 3 power 0 is 1 minus 3. So we have here 1 squared is 1, plus 2 times 1 is 2, minus 3. 1 plus 3, 3 minus 3 is equal to 0. So it is when n is equal to 0 that this equation is satisfied. Therefore, the value of n in this exponential equation is equal to 0. Thank you so much for watching this video.